So, is it visible?
Yes, sir. Yes.
Thank you, Dr. Chattopadhyay. I will be talking on climate change and agriculture. Friends, you may be aware that World Economic Forum is a body of more than 2,000 experts, scientists working in the universities in the economic aspects, and they meet every year uh, on 15th January. This time they meet from 19th to 23rd January in Davos, and they come out with the 10 most important risks which globe is going to face in 1 year terms, 2 years terms, and 10 years terms. So every year they keep on changing what are the priority. Like 20 before 2020 there was no COVID, but then COVID came in 2021. Like last year it was misinformation and disinformation for the number one threat that has come down to number two. But this year the geo-economic confrontation is the number one threat. Then extreme 10 years period, extreme weather events and the climate change, pollution, cyber insecurity, so even societal polarization, state-based armed conflict. So all these things, whether it is climate change, this is the societal inequality in various aspects. They provide these risks, and every year this report comes on 15th January, generally. Uh, Coming to the climate change is a very new subject. It is only 47 years old subject. Nobody was talking about the climate change before 1979, when first World Climate Conference was held in Switzerland. Sweden, sorry. Okay. Switzerland. What's the problem? Okay. First World Climate Conference in 1979, and the scientists agreed that uh, there is definitely science behind the climate change, and it resulted into the formation of intergovernmental panel on climate change. I will be talking on these aspects also. That climate variability change is an issue of the concern worldwide. First time this authoritative statement come. Then second World Climate Conference was held in 1990 to make political class aware, because money has to come from the political class only, and that resulted in the formation of global climate observation system and UNFCCC, United Nations framework on climate framework convention on climate change. And the third such grave big meeting was held in 2009, where it was decided that we should go towards societal benefits. Every penny spent on the climate change should be for the societal benefits, and it resulted into the uh, establishment of global framework for climate services. So what is climate in a crux? We should understand what is climate. There are two things. One is climate variability, another is climate change. These two must be distinctly understood. Like when we talk 1 year, there is more than any element of the climate change, more than average year, more than normal. Another year is less than 1 year. Temperature is increasing, another year like temperature is decreasing. This is not climate change. This is climate variability, like sometimes increasing, sometimes decreasing. But if there is only one direction, either say for 10, 20, 30 years or more, it is increasing from the mean or decreasing from the mean, should be one side, then we will call it is a climate, like deviation from mean magnitude. Say temperature of Mumbai is increasing continuously for last 10 to 30 years. So we will call it as climate change. Another is phase difference from mean periodicity. Like generally we call that monsoon is a 100-day system. Either these days should be more than 100 or less than 100. Then only we will call it a climate change. The third is altered frequency of the current, like number of the cyclones. they generally occur five, but if more than five, less than five, should be one direction, we will call this is a climate change. Another is how we can measure, like climate forcing. Climate forcing means net radiation. If net radiation is increasing, we are should we either increase or should decrease. Increase means we are going towards warming, decrease means we are going towards cooling. Air quality and atmospheric condition, how concentration of the different gases is increasing, and synergic impact, like impact of one on the another. Like if temperature is increasing, definitely evapotranspiration is increasing. So climate variability, I mentioned that climate change is 47 years old subject. Climate has been changing in last millions of years due to both the reasons, due to natural variability, due to man-made factors. Like natural variability means volcanic eruptions. Remember three gases, I will come to those on details also: CH4, CO2, and nitrous oxide. Carbon dioxide, methane, nitrous oxide, they are major greenhouse gases and they cause warming. Other thing like aerosols, dust particles, they cause cooling. Like if we have many volcanic eruptions over the world, definitely they will contribute in the cooling, not the warming. This is the one region of the change of the climate in thousand or lakhs of years. Another is variations in sunspot cycles. This is a periodicity of the 11 years. When there are more spots on the sun, less radiation will be coming and vice versa. But its contribution is less than 0.1%. And main cause of the natural variability is Milankovitch cycle. He was a scientist that he gave three reasons, like distance from the earth and sun, if it is nearest or farthest direct impact. Another is like uh, eccentricity, like shape of the earth. Earth is not elliptical. It changes from the relatively it changes from the elliptical to circular. When earth is in the circular mode, we get more radiation, and in the elliptical we get less radiations. And natural variations in concentration of the CO2 and greenhouse gases, because they also occur in the atmosphere in the natural way also. But then human factors, emissions of the greenhouse gases from the industries and other human activities, aerosols, ozone depletion, and lands like deforestation and other land use changes. If we can understand like this figure, we can understand for 60% of the climate change. Say, if I mentioned three gases, and out of these three gases, CO2, methane, and nitrous oxide, around two-thirds contribution is from the CO2. See this figure, if we can construct like temperature and CO2, upper panel is CO2, lower is the temperature, backward towards lakhs, 4 lakh years. When there is increase in CO2, increase in temperature, decrease in CO2, decrease in temperature. Because it accounts for 66% of the warming of the temperature by CO2. So what is facility in this slide? Two aspects. Now, last 20 lakh years, leave 4 lakh years, CO2 never crossed, sorry, what is happening? CO2 never crossed 320, 300 ppm. Now it is 4 to 4 ppm already. So we have already pumped lots of CO2 in the atmosphere and impacts will be visible. Another thing, earlier this change was in lakhs of years. Now it has concentrated to hundreds years. So that is cause of concern whether atmosphere has capacity to adjust this thing. This time, this change is happening very fast. And remember one thing, if there is change of less than 1 degree Celsius in 1000 years, this is gradual change. 1 degree in 1000 years. But if it is more than that, that is cause of concern. And now 1.5 degree has already happened in say 100 years or 120, 25 years. And what will happen if goes 10, 12 degrees? Even in 1 degree, everybody is concerned with the climate change. And if it goes to say 5, 10 or more than 10 degree, what will happen to the globe? So I mentioned about this concentration of the greenhouse gases. It has increased from 278 to 420 was the 2023, and this year it has gone to 424. Methane also, then N2O, and then there are other gases like chlorofluorocarbons, fluorocarbons. These I have mentioned their value as zero, chlorofluorocarbons, CFC, HFCs, 23 CF4, because they do not occur in the atmosphere naturally, and they are man-made and coming from the coolants, refrigerator, like that. And last column, if you see GWP, this is global warming potential. If we compare the power or warming power of the gases, if we allot 1 unit to CO2, methane is 21 times more warmer, N2O is 310 times more warmer, and chlorofluorocarbons and other is consumed even 23,900 times more warm. Even a small amount is very dangerous. WMO during this COP27 in 2020 brought a 50 years report. A weather, climate, water related disasters has occurred every day, taking loss of life of 115 people and causing economic losses to 202 million in these 50 years. Even number of recorded disasters, they have increased by a factor of 5. This is due to the climate change. And one only good thing is that the reduction in loss of life is threefold due to better forecasting by the meteorological and other communities. Even during that year, they also brought out the first time state of the climate in Asia and other continents. I was part of this. I attended this COP27 in Egypt. Even during these 50 years, about 3,500 reported disasters led to nearly 1 lakh deaths and economic losses of 1.2 US trillion dollars. Uh, Even Asia, even most of these disasters were associated with the floods. Floods were responsible for 45%, storm 33%. And even more than, even we go to the floods, there was huge loss. Then 2 lakh 30,000 deaths, even 683 billion USD economic losses, even Asia itself. If we go with the Indian status, India is among the 10 most climate-induced disaster-prone areas in the world. 2.7 million Indians displaced by climate since 2019. India's average annual economic loss due to disaster is estimated to be $9.8 billion. Nearly 60 million people are annually affected by floods. 316 million Indians in 225 most vulnerable districts by 2020-30, and building climate resilience to above climate vulnerable districts is required to survive, adapt, and thrive despite recurring disasters. See, if we see global climate change impacts are not equally distributed somewhere, these impacts are more, somewhere impacts are less, like see Africa, some countries in the say Asia, and even South America, impacts are more, some cases impacts are less. So impacts are unevenly distributed. So there are two things. Climate change, we can observe either with uh, just a moment. Sorry. So when we were talking about the climate change, either we can observe through instruments or through the signals from the fauna and flora. We will see both the things. Uh, Dr. Chato, am I audible? Hello. Okay. Uh, it is okay now. Thank you. So, like when we want to observe the parameters of the climate, because there are no weather and climate boundaries. Air will be coming from one country to another, and we can't go to different countries to measure the parameters of the atmospheric environment. So, what's the option left? So, globally, there was discussion, and these four agencies were tasked to have climate variables data. UNEP, United Nations Environment Program, World Meteorological Organization, UNESCO, and International Council of Scientific Unions. They are having more than 10,000 stations data, and they are sharing with each countries regarding atmospheric data, oceanic data, as well as terrestrial data. These data are being shared among various countries to quantify. So if we take the signals, whether climate change is happening or not, like this is example from Uppsala glaciers, Argentina. Upper panel is photo in 1928 and lower panel is 2004. So upper panel, lots of ice extent was there where that has disappeared. It means something is happening to the climate. Second is say, uh, this is Rheon glaciers in Switzerland. Left panel is 1859. Lots of the snow ice extent is there. Right side must uh, much of the ice has disappeared. So so these are the signals that climate change is happening. There is no doubt. So when in 1988 this IPCC was established, Intergovernmental Panel on Climate Change, it is body of the experts, more than 2,500. They work in their government, their universities, they are professors, they are scientists, they are different, even NGOs. They provide uh, peer reviewed and published data to IPCC. They brought out first report, first assessment report in 1990, second in 1995, third, fourth, fifth, and sixth report in 21 and 22. Three reports, one related to science, like 3,000 pages, one report is there, one on science, working group two on the impacts, adaptation, and vulnerability, and third is mitigation and synthesis of the all these reports, like synthesis report. I will put little emphasis on these reports. What IPCC takes into account? Every bit of warming, even 0.1, 0.2 degree temperature, they take every bit of warming matters, every year matters, and every choice matters. We are burning more fossil fuel, burning more coal, or we are using non-conventional energy, biomass, and every choice matters. So IPCC take all these into accounts. And this is the slide for which IPCC was given Nobel Peace Prize in 2007. If we say first time IPCC came out with an authoritative statement that today's climate change is due to human activities. There is discernible evidence that today's climate change is due to human activities. Why? If we say there is no human interference, then temperature should have been here. This is green color. But if we take observation with the black and prediction using anthropogenic, human made, as well as natural forcing, both are totally matching. So this fast changing climate cannot happen only naturally. Human intervention is the main cause of the climate. So these are the authors of this report from India. Honorable PM called these authors and gave commendation certificate. Okay, let's come to the first assessment report. AR6 assessment report 6 released in 2021. If we see left panel, if climate change like increase is 1.5 degree by 21st 100, so globe will like this, look like this. If there is change in 2 degree, then globe will look like this. And if it is more than 4 degree from the normal in the globe, over the globe, world will like. So there's no doubt that globe is heading towards the warming period. Every year is breaking the record of the previous year. Say 2020 it was 1.2 degree, 2020 1.11, 2020 to 1.15, 2023 1.45, 2024 1.55, highest than this year also 1.44. Last 11 years they have been warmest on the record, say last many lakhs years. So this is cause of concern because every year we are going more and more warmer. So these are the anomalies and extremes in surface air temperature in 2023 to the last 3 years. You will see many places. There is increase in temperature. Only some places there are there, like some India was not that warming than some part of Africa, South America, and like that. But if you see the 2023 more war, 2024 is highest, more and more warmer, 2025 little less, but you will find that there is no doubt the globe is warming up. If we take hot extremes, temperature if it increases from the say 1.5 to 4 degree, there is chances that the extreme events, extreme warming events will increase 9.4 times. In 10 years period, if we take 50 years period, even they can increase by order of 39.2 times. Now temperature, no doubt that we are heading towards warming. If we go with the precipitation, there is no pattern. Somewhere it is increasing, somewhere it is decreasing. Green mean increasing and others cyan mean decreasing. So total precipitation over the globe remains same, but somewhere is increasing. We have more floods. We are decreasing. We have more droughts. This is cause of worry on climate change. Even heavy rainfall events in short span of time, they are increasing over most land area. This plus blue is the increase and minus red, it is decreasing. Most of the places you will find this plus blue figure is there, whether it is North America, South America, Asia, Australia, even lower Africa, we are finding increase in extreme weather events. If we take, say, by 2100, future global warming events, 10 years period, these extreme events will increase 2.7 times more as compared to 2020. Even 10 years period, they can increase by order of 4 by order of 4. And by 2021, sorry, this is up to the end of this century, temperature increase can be 4.4 degree, ranging from 3.3 to 5.7. If we don't take much actions, but if we take more and more actions like SSP2 scenarios, it may temperatures like 2.7 to 3 degrees centigrade. So we should have to control this. The second comes this working group to impacts adaptation and vulnerability. Globally, 3.3 to 3.6 billion people live in areas that are highly vulnerable to climate change. And 15% of the land and 21% of forest water and 8% of the oceans are the protected areas. And increasing temperature present 127 key risks, which include food security, water security, forest fires, health, transportation system, urban infrastructure, flooding, marine resources, and even extinction of the species. And we need $127 billion by 2030 and $295 billion for adaptations in the developing countries. If we go to the working group 3 by 2030, we have to reduce greenhouse gases by 40 to 70% by 2050. Zero energy, zero carbon building in most of the climates, that is all being talked. Even limiting the warming, we already reached 1.5. Limiting warming around 1.5 degree requires global greenhouse gas emission to peak before 2030 and reduce by 43% by 2030. So these are the huge target. Even this assessment shows that warming around 2 degrees still requires global greenhouse gas emission to be reduced by 2030. So lots of the actions they are required. I was talking of the globally. Let's talk something about the Indians status. Like India also, we are heading towards warming. Climate change is happening. Even if we go last 2025, 125 years data from 1901, increase in maximum temperature has been 0.89 and minimum 0.4 degree and average temperature like 0.6.8. India is also warming, but not at that level like a globe is 1.44. But there is no doubt India is also heading towards warming. As far as the rainfall is concerned, somewhere it is decreasing and somewhere it is increasing. You can see with the mean variations are there for last say few years. We are in the plus phase, but total rain remains same, but regional variations are there. So if we take these two things, 75% of the rainfall we receive in the monsoon season. So left is monsoon, right is annual. So pattern are same more or less annual and this monsoon season. One total rain remains, but say if you go the subdivision wise, one bad thing that rainfall is decreasing in the central part of India, both in the annual and monsoon season. This is cause of worry because rain-fed agriculture is more and more in central areas. If there is good rain, we have good agriculture. If there is no rain, we had bad agriculture. And another mention like globe, in India also, low and moderate events like 1 centimeter rain in 24 hours, half centimeter rain, 3 centimeter rain, both events are decreasing. And like 10 centimeter, 15 centimeter or more rain in say 24 hours or like that, they are increasing. So more flooding is there, more drought is there, so more uh, climate extremes are there. That is cause of worry. If we go to the heat waves, like up to 1990, there were 500 heat waves, then another 10 years, 580, and then next 575, and the latest decade, 2010 to 2020, there were 600 heat wave days in India. And if we go to major extreme events like cold waves, snowfall, heat waves, lightning, dust storm, thunder, we are having different type of the uh, extremes, weather extremes occurring in 2025. This is the pictorial representation. Then many people were saying that uh, what is happening to the uh, climate, particularly during the monsoon. Then, because climate change is a very recent subject, 30, 40 years, I also mentioned that. Then India Met Department carried out a study in different parts of the country, taking recent 30 years data from 1989 to 2018. And remember, 5 states, Uttar Pradesh, Bihar, West Bengal, Meghalaya, and Nagaland, they showed significant decreasing trend in southwest monsoon. And if we add two more states, Arunachal Pradesh and Himachal, then 7 states annual decreasing trends, they were definitely significant. Others somewhere is increase, somewhere decrease. And even our sister organization, IIT Pune, under Ministry of Earth Sciences, they projected what will happen to the climate in next, say, 80 years or like up to 21st standard. That India also, average temperature has risen by zero point 0.7 degree during the last 118 years and projected to rise between 2.7 to 4.4 degrees centigrade in best case and worst case scenarios. Summer monsoon has declined by 6% in Western Ghats and Indo-Gangetic plains. Temperature of the Indian Ocean has risen by 1 degree during last, say, 75 years, which is higher than the global average. If we go to even like a subdivision, we have 36 subdivisions in the country. Somewhere rain is increasing, somewhere rain is decreasing, red, and this green is increasing, other color decreasing. So total rain remains same, but central part, particularly northeast, rain is decreasing. So what we need? So there is no doubt whether it is India, these are our neighbors, these are various parts of the globe. Climate change is happening, extreme weather events are increasing, floods and droughts are increasing. We want a world, sustainable world. Like left side is the total develop construction like that. We can't have that one. Right side total environment, because we globe has more than 7 billion population. So we need to have to sustain the population. The development is required. Sustainable environment is required. And globe has 17 sustainable goal, like no poverty, zero hunger, like that. Sustainable agriculture and all these parameters, even climate action. So total 17 sustainable goals are there, and world is aspiring for those goals. And remember one thing, this distribution of vulnerability, I showed one slide, it is different in different parts of the world, but distribution of vulnerability up to 2050, say next 25 years or 24 years, is not that serious. You will find, except few places, it is of the moderate category. But when we go beyond 2050, most parts of the globe will come in severe to extreme categories of the vulnerability. So definitely there is time we must do the different actions. Like 2015, then COP21 was there in Paris Climate Agreement, first time happened, and different countries were given targets how much greenhouse gases can you reduce. Like NDC is nationalized, national determined contribution. So how much greenhouse gas you can reduce? Every different countries take different pledges. We will do like this. And there was target that we should keep temperature of the globe increasing by 21st century by 1.5 degree and maximum 2 degree. What is philosophy behind 2 degree? If we can uh, arrest within 2 degree, thousands of the islands and many low-lying countries will be saved. Otherwise, they will be underwater if it goes beyond 2 degrees. That is the synthesis of 2 degree. So 170 parties out of 197 have ratified the convention. And when we talk about the who is emitting what, like right side, this 15.5 tons per capita, this CO2 emissions from the US, 12.5 is the Russian, China is 8.1, Europe is 6.5, and India is 1.9. But they don't agree. They say, no, 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 we can't go per capita. We go, let's go total now. China is the number one emitter of the greenhouse gases. Then US number two, EU three, India fourth, and Russia 15th. So people keep on discussing how much emissions is there and what should be reduced. India, this is Panchamrit. They take 5 pledges that India will reach its non-fossil energy capacity by 500. Now we have increased this year up to say, 600. Then India will meet 50% of the energy requirement by renewables. Then by reduce carbon intensity by 45% and a net zero target by 2017. And remember one thing before coming to the agriculture part, that 50% we can go up to the non-conventional energy. Remaining 50% from where it will come. This is the slide. We can say from where 50% will come, like green hydrogen. We have read in our school and colleges that if you break water at high temperature, it is broken into hydrogen and oxygen. Oxygen will be released into the atmosphere and hydrogen for power use. So this is the win-win situations. But if we use blue natural gas for producing hydrogen, it is called blue hydrogen. If we take natural gas also and release CO2 in the atmosphere, that is called gray hydrogen. If we use solar energy or nuclear energy for producing greenhouse, they call yellow hydrogen or pink, red, purple. But if we use say coal or lignite for producing green hydrogen, that is most dirty, and that is called black or blue hydrogen. This is most damaging for the environment. Nobody should use those hydrogen. Now challenge is there. When climate change happening, we we have to take different action, like how to introduce green technology and what scale. Non-conventional energy, how much we can use. Like CFL cost is 100 rupees. If it can come down to 10 rupees, many people will use. We must have many programs because many participants are from the university research institutions, and they can influence NGOs, students, and other society peoples. They should adopt green technology. Electric powers, I have mentioned, identifying suitable space for installation of solar panels. Cost of generation of this energy should be reduced. Strong insurance components should be there when we are changing the technology. Government should do many things. Climate resilient cities, like planned cities, not constructing a hazard manner, and capacity building program like today we are meeting and we are discussing with each other what climate change is happening, what should we do. So when we take the climate change and how it is affecting agriculture, there are different issues. The regional impacts are different, global impacts are different, and local impacts are different. We should know different effects, how it matters to the climate change, and what are the adaptation uh, options, what are the mitigation options. Detection and attribution is very important. Vulnerability assessment is very important. Strategic adaptation, I mentioned local, regional, national, or global levels. Then key questions for decision making. How much, at what level we should take actions. Like food demand will rise, we know that in order to meet the global demands, we will need 60 to 70% more food from today by 2050 in the era when climate change is happening, population is increasing day by day, land is also decreasing, or land is degrading and decreasing. But still, we have to increase food. So there is more responsibility on the agrometeorologist and agriculture scientists how to cope up these climate change implications. This impacts of climate change on agriculture, that there are different studies like greater loss expected in the rabi crops. Every 1 degree increase in temperature reduces wheat production by 4 to 5 million tons. Loss only 1 to 2 million tons if farmers could plan in time. So adaptation has much meaning, and we must put emphasis, and that should be part of our different agromet advisory services and other agriculture services. Reduced frequency of the frost damage, less damage to potato, peas, and mustard. We should do that. Increased drought and floods are likely to increase production variability, and cereal production to decrease by 10 to 40% by 2100. So, picture is not rosy, but we must do or take all these actions. Then climate change effect on agriculture, because there is a projected reduction of 3 to 23% yield reduction in major crops by 2050. By 2050, and when we take average from 2040 to 2069, if no adaptation for climate change is uh, followed, changing climate will require increase in water requirements. Some areas due to erratic rainfall, while others will experience crop damage due to flooding. Soil quality, I already mentioned, that will be deteriorating due to temperature and augmented erosion. Climate change would also aggravate the impacts of pest and disease. Unfavorable temperature and moisture condition will significantly degrade the quality of food gains, hence affecting the nutritional security. And climate change poses significant risk on food and livelihood security. And one thing up to 2020 that people now want quality food, not only quality quantity, but quality food which can increase our immune system, like coming future pandemics, this COVID and others. So our immune system should be more and more strong. So we need to produce better and better quality of food. Like projected impacts on the crop. This is in India study from Naresh told at IRI: wheat, irrigated rice, rain-fed rice, mustard, rain-fed sorghum, irrigated soybean, potato, and coconut. These are the three crops which show that in the era of climate change we will get beneficial impacts, but other most of the cereals impact will be in the negative direction. And one thing, this is picture like Indian summer monsoon rainfall and crop production. When rainfall is increasing, this crop production is increased, but after a certain period, this is not a straight line. This is becomes curvy linear. Like that impact is not much more like if we go negative rainfall like -5, -10, -15, -20. Definitely there is decrease in crop production. If we go in the plus, definitely there is increase. So there is direct relation of uh, total rainfall, monsoon rainfall with the crop production. Many of you must have seen such impacts. The adaptation is important. Two things I mentioned: mitigation and adaptation. Both are important. Adaptation means our decisions, and agrometeorology is most important because it is less capital intensive. Money we have to put money. We have to change technology. Like what adaptation? Like we change type genotypic and crop management, like uh, rainfall is said late this year, we will sow our crops late, or these type of the uh, within season as well as before the planning of season, we can take decision. Then what is the climate change? We must know main changes, uh, the agromatic management, resource management, natural resource management, weather-based agro advisories. You must have uh, seen in other lectures, contingency plans, input use agencies. We have to adopt all these uh, parameters. We must also think agriculture as a part of the solution. Always not say agriculture is the problem. What solution we can take? Increasing carbon sequestration through land management. Definitely, when less greenhouse gas emission will be there, there will be a decrease in the temperature, this climate change happening. Rotations with cover crops, green manure, these can help. Agroforestry, conservation tillage could reduce global CO2 emissions by 5 to 15%. Even organic farming will impacts, benefits, impacts are limited, but definitely that is better, and that enhances carbon storage in the solution. So agriculture could be used as a potential beneficial solution to the climate change. However, impacts are very serious, but some positive things are also there from the agriculture. So adaptation can improve the yield and farm health, like impacts. The left column is there, then sowing date, then plus variety, irrigation efficiency, fertilizer, and additional inputs. With the adaptations, we can reduce impact of the climate change. Like see, timely sown with impact. Now the impacts in many parts. But if we have adaptation, see agro services, see weather advisories, we can reduce impacts of the adverse weather on the yield of the wheat. In this chapter, these are the different crops: wheat, rice, maize. These are left are irrigated, right are the rain fed. But whether it is rain fed or it is irrigated, with the adaptation, we can cope up with impacts of climate change to certain extent. So we need climate smart agriculture. Everybody knows sustainably increasing agriculture productivity, then adapting and building resilience to climate change, reducing or removing GHG emissions wherever possible. This climate smart agriculture is an approach to developing all the three uh, streams, whether it is technological issues, policy issues, or investment conditions to achieve sustainable agriculture development. If we see technology, understanding the vulnerability of the system and its component, developing alternate farming system, technical aspect we should consider germplasm utilization, data-driven technological intervention, adaptation, niche areas, mitigation strategies, market demand intelligence. All these issues, they are uh, technical intensive. So we what technology at the global level, regional level, or in the local levels, we can use in our farm management decision. As far as the policy is concerned, because policy has also monetary component, increase budgetary allocation to R&D and capacity building, minimum farm income support, insurance safety net, rural agriculture infrastructure, mainstreaming technological interventions, crop production zones, marketing organized farm sector, agri business, input output service provider, all those are required. So technological advance to minimize climate change impact, whether it's global, this big data analytics, people are now talking precise farming, protected cultivation, farm mechanization, livestock management as far as India, adaptation of options for diverse conditions, climate resilient cultivars that is required everywhere. So we have to we have to think globally but act locally. So these are the investment opportunities are there in agriculture, business management, crop residue burning, vermicomposting, CBG plants, energy briquetting, boards, handicrafts are there, small scale farming implements, energy efficiency, then low cost weather stations. So for the particularly new scientists, they are very much investment opportunity. ICT tools are there. Agriculture business, people can take agriculture as a business and can uh, use all the policy, technological as well as investment opportunities to sustain the agriculture output. The financial sector, servicing, credit, agriculture, insurance, all has to be integrated. But one thing we should remember, a couple of slides are more, the limits to adaptation. It is not like impacts are huge and we can reduce everything. So there are limits to how much we can prepare for and how much water is available, how much resources, how much money, how much physical barriers are there. Physical limits, I mentioned what are the ecological tipping points. Social limits are there because people generally don't change their habits. Economic limits, how much money is there with the uh, developing or developed countries. Not all development will reduce vulnerability to climate change. Getting rural development right means that vulnerability to climate change must be reduced. Agriculture development must think about long-term change and must be flexible. We must not be very rigid. So this is all with climate change and uh, agriculture. So thanks for patient hearing.
Thank you, Dr. Navanshu. May I audible? Is there? No. This, this one. Is there? No. I have to. Okay, you can do this. Yeah, I have stopped the sharing. Yeah, yes, sir. Yes, sir. Yes, thank you, Dr. Navansu. It was indeed wonderful lecture from our senior colleagues and a functionary in Government of India, Dr. Attri. He started the genesis, the consequences, the challenges, and wonderful from zero to the sky. So we are very thankful that we had a chance to see the comprehensive lecture. Now he is also serving the uh, health sector of government of India and this region in NCR. So thanks, Dr. Attri, courtesy Dr. Navarzo. In continuation of climate change and its impact in agriculture, I have to supplement with some more awareness program slides in the region of South Asia. So we will be there for a couple of minutes. Next, sir. In our lecture, there will be understanding about how climate change fundamentals. You might be well aware about what Dr. Attri has told you, then interpret observed and projected climate trends. You might be well aware by now. Now then assess impact on agriculture. Yes, in comprehensive terminology, Dr. Attri has also give some idea, and then explore adaptation and mitigation strategy, which are the cause of concern and one of the biggest tasks for all of us. Next, sir. Next, yes, in the context of climate change, it's, as in 2007, the Nobel Prize was shared by IPCC and Al Gore. It was very timely and a importance was given that climate change is there and it has to be dealt with, otherwise peace will be at stake. So in agriculture, both influenced by and contribute to climate change. Yes, it is influenced being a natural entity in open, but it's also contribute to the climate change besides the natural and other anthropogenic activities. Then we have to understand long-term trends vital for resilient agro-food system. But food is the ultimate. Humanity or any biological entity has to thrive on food, and food is to be sustainable throughout for our survival. And what IPCC in its annual report of Action 6 emphasizes regional adaptation and risk management. Because when we go for a comprehensive or continental or global basis, then the effect may be subdued or diluted. So they advocated the regional adaptation and risk management in agriculture due to climate change. Next. As per definition, what we have so far understand that long-term alteration in climate system is the climate change. It includes generally temperature, rainfall, and extreme climatic events. It is always driven by natural and anthropogenic. If it's in a slow process, less than a degree in 1,000 years is normal change because it's a dynamic throughout. If it goes higher than 1 degree within 100 years, then the cause of concern. And the anthropogenic activity, the men who wish to be more comfortable doing intensive development, and they cause the faster climate change. Next. The climate change, you might be well aware about how it is happening and what are the parameters which are more concerned, like temperature, rainfall, wind pattern, and other elements of Earth's climate system. If you observe, if you are a keen observer from the day 1 of your life, or when you started, or we started our mind-boggling observation, then we came to know that yes, it's always is already happening, and various activity by men for his comfort due to intensive development, more industry, more transport, more exploration in space, and all those activities by men created a lot of greenhouse gas emission, then more land for our uh, developmental activity through deforestation, because earth and or the land is limited, and then for that we have to have some activity a man has to, then that cause the climate change. Next, variability and change. As we are well aware about for short span of time, any variation or any up down in a climate system is known as variability. If variability for longer period and established either in the positive way or negative way, increasing or decreasing, then we call it a climate change. It's climate change is very important for agriculture planning, because climatic variability, plant or the crops have inbuilt capacity to cope up with. But under climate change, every variety or every crop has certain requirement. If it changes, then it is very tough for that those varieties or crop to sustain, to provide good yield, or to secure food system. Next, the driver of climate change, we are well aware about the volcanic activity, the solar variability, the distance of Earth from Sun, and all those activity under comes under natural drivers, and the man-made drivers, the use of fossil fuel, land use changes, and these are the major drivers, and they cause the global warming and the ultimate climate change. Next, then there is a feedback mechanism of how these gases or water vapor or ice, they revert to the in the atmosphere, and they keep on continuing throughout their feedback system, and they have their life cycle in the atmosphere, and they goes on increasing through the feedback system of ice or snow, and then water vapor, and then carbon cycle feedback. And these are the cause of concern while increasing the greenhouse gases or heat trapping, and ultimately to the climatic variability and change at a longer space of time. Next, the most important greenhouse gases, CO2, methane, nitrous oxide, and water vapors, and they are in a different quantities. When goes on increasing, they increase the greenhouse effect, like when we have cloud in the night and we have different high temperature. Likewise, these gases create a blanket type in the atmosphere, and they don't allow to revert the heat or trap. Then this is a greenhouse effect, and ultimately this creates some warming, or if this is for a globe or planet of Earth, then we call it a global warming. Next, the various lifespan of these greenhouse gases in the atmosphere, because the major is CO2. It is coming from burning fossil fuels, deforestation, industry, and then most abundant human caused greenhouse gas we grade it. Then we have methane due to livestock feeding mechanism, the rice field in agriculture, the landfills, natural gases, and it's stronger than CO2 per molecule, as Dr. Attri has shown in one of the table in the last column, how they are important from one another. The nitrous oxide, fertilizer, soils, and combustion, these are the activity or the sector we are getting, and its long atmospheric lifetime. Then water vapors, evaporation from ocean, lakes, and plants, most abundant natural greenhouse gas. Ozone is a tropospheric ozone near the Earth's surface. It's a formed from nitrous oxide and the in sunlight is a secondary pollutant. Nowadays, it's also being measured by IMD, it's a network scale. And then CFC, chlorofluorinated carbons, due to refrigeration, hypersonic planes, and the electronics, is also a quite warming potential. And these all different gases create ultimately to the heat trapping, global warming, ultimately to the climate change. Next. Then the trend of global temperature after industrialization, it is average temperature of the earth has increased. These are the genesis of IPCC in late 80s. Why it is increasing, what are the reasons, and how it can be checked, and what, and then everyone is involved, and then these created a system so that we can search for better life on the earth in times to come. So over the year, the changes are there from 1880 to 2023 or thereafter also. It's always an increasing trend. Next. Here also we have global average temperature changes since last 10 or so year. Every year we have a record of higher than previous years. The global mean temperature has risen approximately more than 1 degree since 1850. Increased frequency due to high temperature, we have frequent heat waves, droughts, and extreme rainfall is a cause of concern at global level also. WMO has also started observing or monitoring and then recommending some precautions or for heat wave and drought and extreme events also. And CO2, current level of CO2 is as last week I have got it from Mauna Loa Observatory in the Pacific Ocean. It is about 431 ppm. Otherwise, during at the time of industrialization, it was around 280, and it is being uh, advocated by the expert that CO2 around 350 ppm is quite good enough to sustain the life or to sustain the development in a long lasting manner if it is 350, and also a drive is there at global level to keep down the uh, CO2 level, but still every single week it goes on increasing. And then India also too around more than 0.7 or 8 as the changes of temperature in a positive way. Warmer nights are there, erratic monsoon, and the today at 8 p.m. we got some private agency monsoon forecast for this year, and they are very skeptic about the below normal rainfall, but we have to wait for official forecast of India Meteorological Department is likely to be in this very month for the whole region, you can say. Next, then future climate scenario, we have warming increase as the target fixed by the WMO IPCC 1.5 degree under scenario 2 to 4.5. Metro is likely have up to 4 degree by the end of century. Then it will create rainfall variability and evapotranspiration variability, changing pest disease dynamics and soil moisture decline. Yes, every normality is likely to be affected, and ultimate sufferer will be the activity which are in open or like agriculture. Next. Ultimately, how changes in climate or the established changes we can climate change, we are likely to have impact on crops, yield decline in rice or wheat up to 10%, 6 to 10% per degree Celsius rise. Maize and pulses highly heat moisture sensitive. They are likely to have some advantage over C3 plants because fertilization is more in C4, and the crop like maize, sugarcane, millet, mustard, they like hot weather climate. They may have some advantage over the C3 plants, which are generally grown in winter season or cool or moist environments. Next. Then impact on water, livestock, fisheries are also the food producing system and very comes under the agriculture. And in water surface, water availability is likely to be down up to 30%. Rising irrigation demand due to high rate of evapotranspiration. Then our livestock, heat stress, reduce milk yield and the fertility, and we're likely to have very bad impact on our livestock, poultry even. Then fisheries, ocean warming alters fish migration and its biodiversity. And a lot of people on the world, they depend upon this fisheries, and they are likely to have bad impact due to changes pattern of climate change around their habitat. Next. Then crop wise, how many type of physiological activity they affect? When heat stress is there, then high temperature exceed crop optimum range, then it cause leaf scorching, wilting, and reduce growth. Then it will be tough for crop to revive. Severe heat during flowering leads to poor pollination and grain setting, like terminal stress nowadays, or in winter season, when high temperature in the end of March or mid-March, then the terminal stress create problem for heat yield in the northwest India or some other part where the when crop is at the final stage of ripening, and due to stress in temperature likely to have cereal grains or decreased yield. Then shortening crop duration due to these changes, we have reduced number of winter or growing season, and then the whatever variety are there, they are being developed by the expert as per the availability of climatic resources, agroclimatic resources in that region. If that zone has reduced agroclimatic resources, then that particular variety likely to suffer. And we have some management issues which can overcome to a certain extent, but ultimately the breeder has to go for the agriculture scientist or biotechnologist has to go for another variety which are resilient and suited for that particular the region over a decreased duration of the season. So it is very tough job because to develop a variety it takes years together. And if we use very high-tech agriculture like biotechnology or some speed breeding, we can come across, but these are short measures to be taken. Reduce photosynthesis, high temperature damage enzyme and chloroplast. Yes, we are unable to have good yield due to these enhanced activity while producing food through photosynthesis. And then reproductive failure, pollen sterility, flower drop, poor fruit and grain formation. And nowadays, when last 15 or 3 weeks in northwest India, we have a lot of rainy activity, high speed. It also create problem for fruit growers, and we are likely to have bad impact on the next crop of fruits in the region, in the overall country, where the eventuality of weather are being faced. Then changes in dynamics or increased pest disease incidence. Yes, when changes are there, new insects or their damage are increased, and we have to control them, and then a lot of other chemicals, and then create again a environmental hazard, and a lot of economy is involved, and These are the practical impact on crop at a very farmer level in the region. Next. Then socio-economic impact, increased crop failure risk and rural income instability. Yes, when these are happening, then every sector of the economy is under stress to make them survive, to sustain the life under crop failure or rural income instability. Market even flourish when good crop is there. But they are purchaser or user of the all sectors, a huge population in India and in other South Asia. If they are good at their agriculture or in production system, yes, market is smiling with enhanced purchasing power. Likewise, migration and urban pressure to intensify. If agriculture failure is there in the villages, then the people will come to the urban area, or they have to migrate from here and there. It's also create problem for whole system or the resources at which they are initially prepared. Then insurance and adaptation policies become vital. Yes, if we have to pump some money or funds for those sectors under stress, then everyone has to pay through insurance and adaptation policy. So every sector is under stress when climatic stress are there on agriculture. Next. Then global case studies, yes, because at a global level, using various models or some AI techniques, the expert has found that sub-Saharan Africa, they are likely to have higher maize yield, because maize is a C4 plant, is likely to be enrich activity photosynthesis in higher temperature. They are likely to have, no, but rather yeah, is likely to have decreased yield. And US Mid East corn soybean belt shifting northward. Yes, yeah, it may be there. Shifting is maybe good for the country, but not good for the grower or the farmer, because they can't leave their land holding and they can't move from here to there. They have to remain there. So in US Midwest, it's likely to shift of corn soybean. In Europe also, heat stress affecting cereals and vineyards at global level. Some examples are there. Next, while taking about India, in Northwest India likely to have wheat yield decrease by 20% under RCP 8.5 scenario. Eastern India likely to have more flood and submerged rice. It's a bad for paddy cultivation, rice cultivation. Then Deccan Plateau in southern India, drought stress on millet and cotton also affect badly. Then coastal salinity intrusion is there in paddy fields in the coastal region. It's a case study about India. Then next. Yes, then our South Asian regions of saffron, we in Afghanistan, what we got from the various studies, persistent decline in cereal productivity due to temperature rise and reduced rainfall. Nowadays, they have unusual rainfall this very month in April. Agriculture employing around up to 80% population highly exposed to climate shocks. Wheat is the most climate sensitive, likely to have around 28% decline. Rice shows relatively smaller decline up to 6%. Drought and desertification are the dominant driver of productivity loss in Afghanistan. The next, then in Bhutan, high variability rather than uniform decline, because it's a hilly state country due to mountainous ecology. It is being projected that yield decline up to 7%, buckwheat, then up to 50% crop loss in extreme pest disease outbreak, frequent droughts, flood, landslides affecting yield annually. Generally, Bhutan is a natural farming country, and if you depend on nature, then if changes are there, then the flurry are also creating problem or losses are more significant. Next, then we have Bangladesh. Wheat is the most vulnerable, up to 70%. Dr. Navansu has already done some projects there on agro advisory services and well works with the agro system. And rice shows moderate but widespread losses up to 20% under extreme weather conditions. Extreme events and salinity intrusion are there in a dominant way, and the pulses and oilseed also likely to decrease up to 10 to 30% under drought prone areas in Bangladesh. Next, in Myanmar, estimated yield reduction is 10 to 20% under heat and moisture stress. These countries, they don't have very big plains like India, and their yield reduction is higher than Indian scenarios. And in rice, moderate but widespread impact is there. The loss of rice production is up to 10%. Dryland crops like pulses, oilseeds, highly vulnerable up to 30%, may lose up to 30% yield. Then extreme events are the dominant factor rather than the gradual warming alone. Yes, there are frequent floods or the persistent drought may create more problem in Myanmar. Next. Then in Nepal, rice minus 5 to 10% decrease per degree Celsius and up to 10 degree in drought years. Maize is quite likely to lose up to 20%, wheat up to 15%, and other traditional crops in the region in Nepal up to 10% they're likely. High annual variability due to monsoon dependence. They are also under stress over the time in times to come. Next. In Pakistan also the wheat staple crop like in northwest India, they have declined up to 6%. Like in India also rice, basmati and other Eri types varieties, they are likely to up to 15 to 18% under the change scenario of climate change. Then maize likely to have 10 to 20% decline due to heat and water losses. Widespread yield decline expected across various major crops like wheat, rice, maize, cotton, sugarcane system in Pakistan also. Next, in Sri Lanka also rice is likely to decline up to 15% per degree Celsius rise in temperature under the scenario. The tea plantation crop will likely to lose about 20% maximum yield under prolonged drought conditions. Maize and other field crops likely to have 10 to 25% under different scenario of heat and moisture stress. Then overall agriculture impact in Sri Lanka like estimated to be 10 to 20% of national productivity by mid-century 2050 scenario. Then next, yes, to adopt under these changing conditions, the expert has to develop heat tolerant crop variety. It's a time consuming strategy. It takes time to develop such varieties and then adjusting sowing dates. It can be there up to certain extent, but we can't go every time to alter the sowing dates depending upon the intensive cultivation. Then efficient irrigation means yes, we have to have various uh, machinery like leveler or laser leveler or drip irrigations or sprinkler irrigation or whatever other means to have efficient management practice depending upon ET or other scientific basis. Then mulching and shading, yes, that is possible when we have not so intensive cultivation, but if we have our restoring agriculture activities, then conservation agriculture is coming in a big way. Yes, climate resilient crop variety. Yes, already there. Efficient water management. Yes, diversification. Yes, multiple crop shown are to be there. Then agroforestry. Then integrated nutrients management. Yes, to check the environment degradation, and then integrated pest management, then weather-based agro-advisory is one of the essential associate for climate-resilient agriculture, then protected cultivation possible only in vegetables, crops, then livestock and farm system approach. And if we adopt all these in a mix or a comprehensive way, then we have some relief to sustainability under the climate changes. Next, then as Dr. Attri has already advocated about warming and extremes are increasing, what we are seeing or what the models or the studies are depicting, we have to have very proactive action required. Yes, everyone has to be proactive to manage his or her around climate. Shift from reactive to anticipatory climate management. Yes, we don't have to be reactive, we have to anticipate. Yes, it's likely to happen and we have to manage accordingly. We means everyone on the earth from top to bottom or bottom to top. AI and farmer feedback loop key to future ready agriculture. Yes, nowadays big data analysis, machine learning, artificial intelligence has to have the farmer feedback and how to guide them for future to sustain uh, climate resilient and for food security. And future of farming lies in understanding weather rhythm. Yes, we can't go in a average way or normal way. We have to follow or predict accurately the weather rhythm, and then we have to go for farming. Next, next, sir. Yes. Now, as our expert along is already there, our senior Dr. Attri, we are open questions and interactions. That was all about my lecture. Next, sir. Thank you. Thank you very much, Dr. Vanshu. Sir, in the times to come, our colleagues from different countries of South Asia, they will be the focal point for their government to survive under what is likely to happen climate-wise or agriculture-wise. So they are to be visible, and they will their expertise will be sought after by their government. I anticipate. Yes, sir.